Okay, let's see how things go. Let's type in our name and do the revision one. And what I've done here, you can see things are a lot cleaner than they used to be. We've got a little plate reader up here, arbitrarily set to 561 nanometers. We're going to need to change that, of course. The tubes you can generate like you did before, one at a time, by generating each individual compound and volume and give them a label and so on. But there's a little shortcut now, which is you can generate a full set, so it's a bit like the yeast 2 hybrid. Okay, the first thing I want to do is just show that relationship between the color and the tris concentration. So let's make a rack of tubes. I'm going to make 5 tubes. I'm going to make 4 tubes. So I'm going to have 4 columns and 1 row. And let's create that. Here are 4 tubes. And I'm going to make a sort of 1 in 5 dilution, so 100 millimolar tris, a 1 in 10, so 50 millimolar, and then I'll do 25 millimolar and 5 millimolar. And what we should see is that that one stays yellow and these all go blue. And if we keep it in water, it should go blue. So let's put in 400 microliters of 100 microliters of this into the first tube. So new, take up 100 microliters and put it in there. Then we'll put 50 microliters into this one. So 100, 50. Then we'll do 25. So suck up, pet out. And then we'll go back and do 5 microliters of this in the last one. So in there. So we've gone 5, 25, 100. 5, 25, 50, 100 of the tris. So let's do the dilutions by putting in the water. So we're going to need 400 microliters in the top one over here. That'll give us our 1 in 10 there. So take up 400 microliters. So we've got a total of 500 microliters in there. It's 1 in 5. Then we'll put 450 microliters into the next one. Then we'll put 475. Now I can't actually do 475, but let's do 480. It's going to be close enough. So let's put it in there. And in the last one, we'll do 490, which has got the 5 microliters of the other stuff in. So that should be fine. It doesn't look quite right though, does it? Did I actually put the solutions in there? I don't know what I did there. Oh no, they are in there. It was just deceiving. I couldn't quite see, but there is the right amount. Okay, so let's mix them, because of course we need to mix them properly, and that's all good. And now what we'll do is we'll get a plate and we'll put 10 microliters of the Bromophenol Blue into each of these front three wells. So let's get 10 microliters and the Bromophenol Blue, 10 into there, 10 into there, 10 into there, 10 into here, and you know what's coming next, and 10 into there. And now let's put 190 microliters of each of these into the well. So starting with, well, let's just do water to start with. So water in here, no color change. let's try the 5 millimolar tris. No colour change. Let's try the 25 millimolar tris. This should give a colour change. Ta-da! And let's now confirm that the 50 millimolar tris gives a colour change. The 100 millimolar tris gives, gives a colour change. And if we use the neat stuff, then of course that will too. So that's pretty nice. Definitely the flip point is around, well, between 5 and 25 millimolar. I'm sure it's 20. Um, in fact, if I just take a little bit of, I could probably work out how much tris to put in there to make that one 25. I just can't can't think of it on the fly. All right, so let's move that plate to one side and do a standard curve. Because funnily enough, if we actually read this plate now, what we'd see is the first two wells have got quite low absorbances, and the next three have all got pretty high ones. So that's pretty good. That's at 561 nanometers. If we change this to 600 nanometers and do the absorbance, then now these are actually off the scale that they're 2, and these are reasonably robust, but a lot less. All right, so let's make our standard curve. So let's make a plate. Oh, what have I done? Oh yeah, you can only have one plate at a time. So yes, that's something I need to change, isn't it? Only being able to have one plate at a time. That's insane. So what I'm going to do is put. I'm going to make a dilution of a big tube of dilution. I'm going to make some 50 millimolar tris in a big tube. So let's make a blank 15 mil tube, and in that tube let's put 4.5 mils of water. So we'll get some water and put it in there. It's 4.5 mils of water in there, and we'll add 1/2 mil of the 500 millimolar tris. So there's our tris. Hopefully there's enough of it. I think there is. And we'll put that in there. And then, of course, the silly thing to mix this, you have to press M, and then you have to sort of suspend disbelief that that hasn't gone all over the lab. That's another thing I need to fix. Probably a little cap to go on there. All right, so this is 50 millimolar. Let's label it. So tris 50 millimolar. That'll be what we do everything in. And let's put in some of this bromophenol blue. Let's do 1 and 2 microliters. Now I know you wouldn't do 1 and 2 microliters. You'd actually do a dilution probably, but let's take 1 microliter of this and put it into here, and let's take 2 microliters of this and put it into here, and then let's go and get 198 microliters of the lovely tris buffer. And what did I do with it? Did I put it in? What did I put it into there? That's crazy. Anyway, I've forgotten what I've done now. Let's put that into there, and let's set that would be 0. Yeah, I think I got that right. Anyway, we'll soon find out. Let's have a look at the absorbance. Yeah, 0.018, 0.325, 0.679. That looks pretty good. So clearly there's a nice concentration dependence. It should be okay to make the standard curve. What I think I would do if I was doing this for real is I would make a new tube, an Eppendorf tube with nothing in it, and then I would put that Eppendorf tube on the rack, and then I would get some of this lovely tris buffer that I made and make a 1 in 10 of that. So I think what I'd do is get 200 microliters of the Bromophenol Blue, and oh no, I wouldn't, because I can't do a 1 in 10 then. Let's do 100 microliters. So 100 microliters of the Bromophenol Blue and 900 microliters of the water into here, mix, and now we've got a 1 millimolar solution. So that 1 millimolar solution, I reckon, is going to be a lot better to do a standard curve. So if I do 10 microliters in here, 8 microliters in here, 6 microliters in here, 4 microliters in here, and 2 microliters in this one, and then put in 190 or so of the nice Tris 50 that we've got made here. So, oh, nice blue color, bluish color, bluish color. It's not all that blue. I'm going to move this tube because it's the pipette was sort of getting in the way of it. But we've put 190 microliters into each of those. Let's give the plate a mix, and let's measure the absorbance at 600. And this is pretty good. Look, this is the 1 in 10 dilution, 0.68, 17, 213, 275, 377. That 377, of course, is 10 microliters of diluted. Previously, we had 1 microliter of undiluted, so they should be giving about the same number, and they're not bad. So that's, yeah, pretty good. Pretty good series of things happening there. Everything's consistent. I like the fact that you can make the tris buffer. I like by diluting the stock. I like the fact that you can dilute the Bromophenol Blue. A lot of latitude for students to try things, so that should be pretty good. Oh yeah, one thing I didn't show you is that if I change the wavelength of here, so at the moment it's on 600, and if I go absorbance, I get these nice absorbances here. If I change that so that the wavelength is say 550 and I do the absorbance, then it all comes down. So in other words, the maximum absorbance is going to be at the extinction maximum. So the students need to pick the right wavelength on the plate reader to get the best sensitivity, just as in real life. All right, good.